Hello everybody, my name is Hassan Abidi, and today I'm going to be going over dependence networks for Professor Farouk Alemi for HAP 823. We will be doing question number 2. In the following data, test which pair of variables are independent and which pairs are associated. First, calculate the goodness of the fit of the homogeneous model. Then progressively remove each one of the pairs from the model until you can find a set of associations that fit the data. So, the Center for Medicare Services reimburse hip fracture treatments based on one price for the hospital, physician, or post-acute care. Each group continues to bill for their services as usual, but at the end of the year, the hospitals that have gone above average bundled costs are penalized, and hospitals that have below average bundled costs receive a financial incentive. The hospital manager is interested to understand which component of the operations contributes most to above average costs. The data shows the number of hip fracture patients with above and below average costs when cared for by various teams of clinicians. There are 5 dimensions in the contingency table: orthopedic surgeon, use of rehabilitation services, use of 2 skilled nursing facilities, severity of patients' illnesses, and whether the costs of the patients exceed the average bundled cost. You are asked to fit a model that includes all pairwise interactions, including OR, ON, OS, OA, RN, RS, RA, NS, NA, and SA. Calculate the fit of the model to the data using a chi-squared, and then remove one pairwise terms to see if it affects model performance significantly. Continue to do so until you obtain the parsimonious model that describes the relationships in the data and whose fit to the data cannot be rejected. Verify that the associations shown in the following figure fits the result of your analysis. For every association pair in the model, significant or not significant, there should be a link in the figure. Identify which arc should not be there and which arc should be there, but is not there. To do this, we'll be using a certain type of a regression called Poisson regression, which is also known as log linear model. In this type of regression, we count the co-occurrences of events by measuring the association between the events. The independent variable is the variable of interest, and so for our purposes that will be observation. The dependent variables are the combination of events, otherwise known in our question as OR, ON, OS, OA, RN, RS, RA, NS, NA, and SA. On the right, we have our model, which includes rehab, orthopedist, SNF, bundle cost, and severity. On the right side, we have a homogeneous model. Currently, our pairwise associations on our model are not all associated with one another. So we would like it to be a homogeneous model before we can begin to remove each association from one another. So our data consists of the orthopedic surgeon, either Joe or Jim, if rehab services were used, which skilled nursing facility was used, A or B, the severity level, and if the bundle cost was greater or below. Next, we need to import our data from our table into an Excel file. In order to do this, you need to organize it by ortho, rehab, severity, SNF, cost, and observed. We need to do this before we can import our data into R. After doing this, save your file as whatever you'd like into your home folder. So before we import our data into R, we first need to binarize all of our data. You can do this either in R or in Excel. Be sure to leave observed as is, since that is our dependent value. So the next step is to import your data into R, and be sure to check the summary and column names to be sure that everything is as it should be. Now we are going to regress our model. So name your model whatever you'd like. Equals GLM observed tilde ortho plus rehab plus severity plus SNF plus cost to the power of 2. Data equals web and family equals Poisson. This creates our homogeneous model, and now our pairwise associations all interact with one another. Be sure to run a summary of the model and record the residual and the degrees of freedom. Before we begin to remove our interactions from our homogeneous model, it's good to know what the 5 dimensions are. O is for orthopedic surgeon, R is for the use of rehabilitation services, N is for the 2 skilled nursing facilities, S is for the severity of the patient's illnesses, and A is for the cost of the patient. For the next step, we will begin to remove each pairwise interaction from our homogeneous model. In order to do this, we will be using a formula as followed. No plus the interaction we are specifically trying to remove. So for this first set, we are going to remove OR. So the formula will go as no OR equals update model apostrophe period tilde period dash ortho colon rehab. Next, we will run a summary on the model and record the residual and the degrees of freedom. So for this first model, we can see that the goodness of fit went up to 198.91 and now has 17 degrees of freedom, which increased by 1 from our homogeneous model. The exclusion of ortho and rehab has led to a significantly worse fit and also a 1 degree gain in the degree of freedom. This model would imply that there's no link between ortho and rehab, and that association, since we removed that association and it was not included in the model. For the next model, we will be doing no OA, and for the next few slides, we will just be removing each interaction. So be sure to record your residual and your degrees of freedom. So we're going to continue by removing our interactions. Next, we are going to remove rehab and cost and ortho and severity. When we remove rehab and cost, we can see that the residual deviance is 504 with a 1 degree increase in freedom. And when we remove ortho and severity, we can see that the residual deviance goes up to 19.4 and also increases in 1 degree of freedom. The removal of ortho and SNF leaves us with a residual deviance of 18.7 and a 1 degree increase in freedom. When we remove rehab and severity, our residual deviance goes up to 15.82 and also increases in 1 degree of freedom. Moving on to the next removal, we remove severity and cost, which leaves us with a residual deviance of 18.6 and a 1 degree increase in freedom. As we remove rehab and SNF, our residual deviance is 16.1 and also a 1 degree increase in freedom. Lastly, we will remove SNF and severity. This leaves us with a residual deviance of 15.84 and a 17 degree of freedom. So after the removal of each association one by one, we can see that the smallest loss in residual deviance is the association between rehab and severity. This is the best fitted model since the residual increase is only 0.51 with a 1 degree increase in freedom. So this is what our model looks like after removing the pairwise interaction between rehab and severity. So since now there's no connection between the two, all the associations are still there. And what this is basically saying is that both rehab and severity are both independent from one another. and have no effect on one another when removed from the model. Although it's not necessary, we can continue to remove more than one interaction from our model. And in order to do this, you would remove the best fitted model, which is rehab and severity, plus the next best fitted model, which is the skilled nursing facility and severity. So to do this, you would write no RSNS equals update model apostrophe period tilde period dash rehab severity plus SNF severity. So for this portion, we can remove a third interaction to see if it has a significant impact on our homogeneous model. For this portion, I removed rehab and severity plus SNF and severity plus rehab and SNF. This left me with a residual deviance of 17.4 and a increase in degree of freedom by 2 since it was 19. The next interaction to be removed was rehab severity plus SNF and severity and cost. The residual deviance that was left with was 19.0 and 19 degrees of freedom. So after the removal of the last three interactions, we can still see that our original finding of RS has still the best fitted outcome with the residual deviance of 15.82 and a degree of freedom of 1. So in conclusion, we can say that rehab and severity are independent of one another. There is no connection between rehab and severity, but all the other associations are still there. What this says is that rehab and severity are independent from each other, conditional on the values of all the other variables.